Section 7.7, base E and natural logarithms. This is the last section in the chapter, which means we'll have a test coming up. To start, when you see the letter E, it's not a variable. It's actually a constant in the same way that pi is a constant. E equals 2.71828 dot dot dot. It goes on forever with no pattern, no repeating numbers, just like pi does. E is a constant. It's a rational. It's used to model exponential growth. And the inverse or opposite of E is the natural log, which we abbreviate ln. To solve base E and natural log functions, we're going to go to that same log option that we found before, and we're going to go over to the right. You'll see both E and natural log, ln. So if we have e to the x power, we want to take this x, we want to get it out of the exponents here. The opposite of base E is to take the natural log of both sides. So natural log of e to the x equals natural log of 8. These are opposites, and they're going to cancel each other out. The x just comes out front like they used to. So the natural log of e is going to equal 1. So we would end up just with 1x. On the other side, we have natural log of 8. We plug that into our calculator, and we get our answer, 2.079. If we have natural log of x equals 5, we're going to do the same thing, except now we have an e, and we have to raise both of these to that power. So e to the natural log of x power, e to the 5th. These are going to cancel out. This is going to come out front again. And on the other side, we have e to the 5th power. We put into our calculator, we get our answer. All those logarithm rules that we covered a few sections ago still apply, and we want to use those to simplify these logs as much as we can. So when we look at this, first off, I see a minus sign. We can make that division. I also see a 3 here, which we can move up to an exponent on that 10. So let's do that first. 10 cubed minus natural log of 8. And now let's deal with this minus sign and switch this into a single log with division between those two terms. 10 cubed on top, 8 on the bottom. 10 cubed is 1,000, so we have natural log of 1,000 over 8. And 1,000 over 8 we can simplify and make 125. So at this point we have it down to a single number. We're still not done though, because we can do a factor tree on this 125. We would get 3 5s, which means we could rewrite that as 5 to the 3rd power. And as a last step, we want to take this exponent and move it out front. That's going to give us our final answer here. Fully simplified, this becomes 3 times natural log of 5. Same thing with this next one. Take this 3, move it up top. Take this 2, move it up top. Natural log of 8 cubed minus natural log of 4 squared. Minus turns into division. 8 cubed over 4 squared. And let's expand both those numbers out. So 8 cubed is 512. 4 squared is 16. Divide those, we get 32. And 32 we can do a factor tree on. We'd get a bunch of 2's, 5 of them to be specific. So natural log of 2 to the 5th. This 5 moves out front. 5 times natural log of 2. Let's do 2 more to get some additional practice using these logarithm rules to simplify expressions. So here we have natural log of 40 plus 2 times natural log of 1/2 plus natural log of x. This 2 is out front. We can move it up top as an exponent. And we have all these things multiplied together. So we have addition of different natural logs. The logarithm rules say that when we have addition, we can combine them all into one log by multiplying. So 40 times 1/2 squared times x, that's in a single natural log now instead of having them separated. And this we can simplify into one thing. So 1/2 squared is 1/4 times 40 times x gives us natural log of 10x. We're going to do the same thing with this next one. 2 goes up top. This 4 goes up top. And again, since we have plus signs in between them, we multiply all those things together. 5 squared times 2 to the 4th times 5y. Natural log of 2000y. These last two have a few additional steps, but they're really not that complicated. We want to solve for x here, and the x is an exponent in a base e function. So as a first step, let's move everything away from that e. We'll start with this 5. Add 5 to the other side. We have 4e to the negative 2x equals 8. We're trying to get this e by itself. So next step is divide by 4. This gives us e to the negative 2x equals 2. So this is where we want to be, because at this point it's just the e on the left side here, and we're able to take the natural log of both sides. Natural log of e to the negative 2x equals natural log of 2. This is going to move out front, and these two cancel out. Negative 2x equals natural log of 2. We want the x by itself, so we're going to divide by that negative 2. Okay, you can just leave it like that, or if you want to plug it into your calculator and get an actual decimal, you can do that as well. All right, this next one, natural log of 2x minus 3 to the third power. Let's say we take this and move it out front to start. 3 times natural log of 2x minus 3 is greater than 6. Get rid of this 3. Cancels. On the right, we have 2. Now we have a natural log all by itself, number on the other side. We can take each of these, put them as exponents on that base e function. These guys are opposites. This is going to come out front, and we have 2x minus 3 is greater than e squared. Add 3 to both sides, divide by 2, and we get our answer.